Spearman's rank correlation. This is a mathematical method of determining the correlation between two variables. So before we talk about this method, let us just have a brief idea of how it is different from Karl Pearson's correlation coefficient. Now, the Pearsonian or Pearson correlation, it tries to find the linear relationship between variables. So in other words, when the relationship is strong, which it means that there's a strong linear relationship between variables. And a relationship is linear when one variable changes at a constant rate or percentage when the other changes. For example, if we look at data and we find that a 20% decrease in price is always followed by a 10% increase in demand, that is called a linear relationship. So that when we have a linear relationship, what happens is when we plot the points on the graph, we get a straight line. Hence the name linear relationship. Now we know that data are not always linearly related to each other. Okay, another relation is they might be non-linearly related, or we have a curvilinear relation. So in those cases where we have a curvilinear relationship, this curvilinear relationship or non-linear relationship, that is where Spearman's rank correlation becomes useful. Yeah, so this method, it evaluates the monotonic relation, and a relation is monotonic when the variables do not change at a constant rate. Okay, so in case of a Spearman's rank, in case of a non-linear relationship, what happens is when we plot the relationship on a graph, we might get a curve. It might look like this, or it might go this way, but definitely not a straight line. And another difference is when using the Pearsonian or Pearson correlation coefficient, we are using the actual data. But in case of Spearman's rank correlation, we do not deal with data, but rather with ranks that have been assigned to the data. And Spearman's correlation deals with qualitative or ordinal variables. So qualitative data such as beauty, honesty, intelligence, this kind of data can be computed using Spearman's correlation. So which means we can find the relationship between one person's beauty and another person's beauty and find if they are correlated. And remember, we will be using ranks. So let us have a look at this Spearman's rank correlation. Spearman's rank correlation coefficient, this is how we measure, where R is equal to 1 minus 6 summation D square n whole thing n square minus 1, where we've already mentioned what they stand for. R is the rank correlation coefficient, D is the difference between two ranks, n is the number of pairs of observations, and in some of the textbooks you'll find that this R is replaced by this symbol rho, but it's all the same. So if you remember, correlation gives us a measure of the strength and the degree, and in practice R does not take values equal to +1 or -1. It is usually values in between. So if R takes values closer to +1, we call that a high degree positive correlation, and is usually if it takes values from 0.8 to 1 in between, that is called a high degree positive correlation. And if it takes values nearer towards -1, that is called a high degree negative correlation. And if R is equal to 0, then that's the case of no correlation at all between the variables. So let us take a sum to understand this. So this is the case when ranks are given. How do we find the rank correlation between the variables? So in this example, the rankings of students in the subjects of English and history are given below. So we have students A, B, C, D, E, F, G, and these are the ranks in these two subjects, which means student A got a rank, got the 6th rank when it comes to English, and he got the 2nd rank when it comes to history, and the same for the other students. So here we have to find the correlation coefficient. So let us solve this sum. Okay, so because if you look here, what we need to apply this method is the value of D, which is the difference between ranks, and the ranks here have been given. So we have to find the difference of those ranks, add them all together, and n here is nothing but the number of pairs of observation. So which means we have to take a pair of data, which means we find the difference of the ranks of those pairs. So this is one pair over here, this is another pair, and so on. So how do we find the rank correlation? So let us denote ranks in English by R1 and the ranks in history by R2. So R1, R2. So let us take the first pair. So let me use another color. First pair, 6 and 2, 3 and 6, that's another pair. 4 and 7, 1 and 5, 1 and 5. The next pair is 2 and 4, 5 and 3, 7 and 1. So we have the ranks. Now we can find the difference between these ranks. Sorry about that, which is nothing but D. We have to find the difference. Let me choose another color. So D, the difference between ranks, is nothing but the difference between rank 1 or R1 and R2. So 6 minus 2, 4, 3 minus 6, minus 3, 4 minus 7, minus 3. So we keep on subtracting these ranks. Sorry, I forgot this one here. 7, another pair is 1. Difference between 2 and minus 4, minus 2, 2 and 6. And we need to sum all the D squares, take a summation of the D square. In other words, we square the differences. 16, 9, 9, square of minus 4, 16, square of minus 2, 4, 4, 36, and if we add all of these, we get the value of summation ED square, which is equal to 94. So now we can apply the formula. We know that R, to find the rank correlation, this is the formula, 6 summation D square n square 1. N is nothing but the number of pairs. So how many pairs do we have here? So this is we use another color. This is one pair, 6 and 2, 3 and 6, another pair. So if we add all the pairs of ranks we have in this sum, so the number of pairs here is equal to 7. So which means there are 7 pairs of ranks or values in this sum. So we'll just substitute the values in this formula. Bracket 94 means 6 multiply 94, 7 square bracket, we get 6 into 94, 564, 7 square is 49 minus 1, which is 7. 49 minus 1 is 48, and this will give us 1 minus 564 divided by 336, and what we finally get is 1 minus 1.68, and if we take the difference, it is equal to minus 0.68. So that is the rank correlation between the rankings of students in the two subjects, and we find here that the rank correlation coefficient gives us a value of negative 0.68. So negative 0.68 is considered as a moderate correlation. Okay, it is considered as a moderate relationship. So we can say that there is a moderate or medium negative correlation between the two subjects, or the rankings of students in the two subjects. Now there are many times when ranks are not given. Suppose we are asked to find the rank correlation and we are only given the actual data. So how do we find the rank, or how do we calculate the rank correlation in such a case? So let us so what we do here is we follow these steps when the ranks are not given. So the steps to be followed are: assign ranks to the data either in ascending or descending order. It means here that the ranks, when we are assigning the ranks in ascending order, it means the largest value is assigned rank 1, the second largest is assigned rank 2, the third largest is assigned rank 3, and so on. That is ascending order. You can also do this. You can also assign the ranks in descending order, which means the smallest value is assigned rank number 1, and the second smallest value rank number 2, so on. The largest value will be assigned the last rank. But remember, we have to maintain the same order throughout. That is, whether we start with the lowest value or the highest value, we must follow the same method. And next, what we do is find the differences, because the value of D is very important in applying this formula, and D is nothing but the difference between ranks. Then we apply the formula of the rank correlation. So we'll still apply the same formula. The only difference is we have to apply the ranks. So let us take an example of finding the rank correlation coefficient when the ranks are not given. So here, this is the example where we have to find the rank correlation from the following data on the age of boys and age of girls. So remember, in using this rank correlation coefficient, the value of D is important, and D is nothing but the difference in the ranks. So the steps to be followed: the first step is to assign ranks to the data either in ascending or descending order. So let us assign the ranks to the data in ascending order. Let me change the color of the pen to make this easier. Let us say let X represent the age of boys, H of boys, and Y represent the H of girls. X represent the H of boys and Y represent the H of girls. So you take down the X values. H of boys 16, 12, 18, 20 and 15. Let me write that properly. And 15. So we'll assign the ranks in ascending order. Let us call this the rank of X. So 20 is the biggest value, so rank 1, 18 is the second highest value, rank 2, 16 is the third highest value, rank 3, 15 is the fourth highest value, rank 4, 12 is the fifth highest value, rank 5. Then we take the Y values down. We have 14, 10, 11, 18 and 21. Now we assign the ranks to the Y values. Here 21 is the highest value, so we'll give it the first rank. 18 is the second highest value, the second rank. 14 is the third highest value, third rank. 11 the fourth rank, and 10 the fifth rank. So now to find D is nothing but the difference between ranks R1 and R2. So now we'll focus only in these two columns, R1 and R2. So difference between 3 and 3, 0. Difference between 5 and 5, 0. Difference between 2 and 4, -2. Difference between 1 and 2, or 1 minus 2 is -1, and 4 minus 1 is 3. Then we square these differences. Square of 0, 0, square of -2 is 4, square of -1 is 1, square of 3 is 9. And next what we do is we add, or we find the sum of these squares, and the answer is 14. So we simply substitute the value in the formula, and here n, how many pairs are we working with? So we have 16 and 14, one pair, 12 and 10, another pair, 18 and 11, third pair, 20 and 18, fourth pair, 15 and 21, fifth pair. So 5 pairs. So here value of n will be equal to 5. So now we simply substitute the values. Where R is equal to 1 minus 6 into 14, 5 square minus 1. This will give us 1 minus 6 into 14 is 84. 5 square is 25 minus 1, and this will give us 1 minus 84. 5 into 24, this is 1 minus 84. 5 into 24 is 120. So this is equal to, if we divide 84 by 120, we get 0.7, and the difference between 1 and 0.7 is equal to 0.3. So therefore rank correlation coefficient is equal to 0.3, but 0.3, this because it's 0.3, this is a case of weak correlation, and this is 0.3, which means there's a plus sign, so we can say that there is a weak positive correlation. There is a weak positive correlation. Now this sum can also be solved if we assign the ranks in descending order. Which means it will be something like this. So for the same values here, Let me use a different color. So we have X values 16, 12, 18, 20, 15. But we'll assign ranks in descending order. So which means the lowest value will be assigned rank 1. Here 12 is the lowest value, rank 1. 15 is the next low value, rank 2. 16 is the next low value, rank 3. 18, fourth lowest value, and 20 being the largest value will be assigned the lowest rank. Similarly for Y also, remember we have to follow the same order. If you're starting with descending order for X, even Y also should be given, we should follow an ascending order of assigning ranks to Y as well. So Y, lowest value here is 10, so first rank, the next low value is 11, second rank, the next low value is 14, give it the third rank, fourth and fifth. So the procedure is the same, we just subtract the ranks, find the square, add the squares, and simply apply it in the formula. So this is another case of the same sum but assigning ranks in descending order.